Welcome to this 8th video of lesson Pythagoras Theorem, Mathematics Part 2 of Standard 10. In last video, we have seen how to prove and what is first of all Apollonius Theorem and how to prove Apollonius Theorem. Now in this video, we are going to see the sums based on it from practice set 2.2. Let's see what is question number 1. Okay, question number 1 is in triangle PQR, point S is a midpoint of side QR. PQ is 11, if PR is 17, PS is 13.5 QR. Now there is no figure given. Let's draw figure so it will be easier as to understand what is the question given. So answer number 1, let's draw a figure PQR. Any random triangle graph figure we are going to have of triangle PQR, where S is the midpoint of side QR. So QR, this is S is midpoint of side QR. Now let's see what is given. PQ is given 11. This is PQ, it's given 11. PR is 70. PR is given 70. PS is given 13. Where is PS? This P and S. Let's join this. So median is given to us 13. We have to find QR. This is our question. Okay. Now here, as we have this median in triangle PQR, we can use Apollonius theorem. So how to write? In triangle PQR, PS is median. Okay. Therefore, by Apollonius theorem, what does Apollonius theorem tells us? That when the point S is midpoint of QR, the remaining two sides are PQ and PR. So let's write that PQ and QR. If you write this theorem in this way, it will be easier for you. So first you write these two sides, which are the remaining two sides. Take the squares, take the sum, and that equals to. Now on the right side, it is 2 times. There are 2 terms on left side and 2 terms on the right. The left sides are the sides which are remaining sides, of which we have not taken midpoint, and we are going to take the sum of their squares. On the right side also there are 2 terms, so it is 2 times. What is it? 2 times its square of the median. What is median? PS. So it is 2 times PS square, and it is 2 times. It is, say, take one part of the side whose midpoint we have taken. So QR is the side whose S is the midpoint, so you can take either QS or SR by any one of this. Suppose I select it is QS and it's going to be QS. Okay, so this is our Apollonius theorem we have written. Suppose if you go wrong here to write the Apollonius theorem, of course your answer is going to be wrong. Now after writing it in correct way, just put the correct values and get the answer. So what is PQ? PQ is given to us 11, so it's 11 square. QR, sorry, here it should not be QR. As we have taken the midpoint of QR, the remaining side is PR. So here it should be PR. Sorry, it's my fault. So PQ and PR, these are the 2 remaining sides. So it's PR, it is 17 square, is equal to 2 times PS square. PS is 13. So 2 into 30 square. Here you have to see that it's the square of PS. So 13 is the median, it's square. And whatever square of the median, and then after that taking square, you have to take the double of that. Okay. So and it is 2 times QS. We do not know QS, so this will be as it is. As we didn't have to find QR, we don't know QS. So let's simplify this. 11 square is 121 plus 17 square is 289. If you are sure enough about the squares of the numbers, write directly, otherwise you have to multiply 17 into 17 to get 17 square, multiply 11 into 11, you can get 120. But I hope as you are in standard 10, you must have learned these squares up to at least 20. Now it is 2 into 13 square is what? 169 plus 2 into QS square, that will be as it is. Okay, so here if you add these two numbers, 9 plus 1 is going to be 10, 8 plus 9, 10, 11, 1 carry, 3, 4. 410 is equal to, either you can multiply this, okay, and get it here, or if you write it as it is 2 into 169 into plus 2 into QS square. Now if you can see, this number is divisible by 2. This is also divisible by 2. And this term is also divisible by 2. So dividing the whole equation by 2, we can get it. 2 2s are 4. Here be careful. You cannot divide 2 once. You have to put 0 and then 2 5s are 10. Or in short, half of the 410 is 205. Dividing by 2, so this will get cancelled. It is 169. Dividing by 2, this 2 will get cancelled. It is QS square. Okay, therefore 205. Take this 169 on the left side. It will become minus 169 is equal to QS square. And therefore QS square is going to be equal to, what is the subtraction here? 5 minus 9 not possible. 15 minus 9 is 6, and here 19 minus 16 going to be 3. If QS square is 36, QS is going to be equal to 6. Okay, so we have got this QS, but we don't want QS, we want QR. We have to find QR, and now as S is the midpoint of QR, so QR is going to be equal to 2 times QS. This is a midpoint, and therefore it is 2 into 6, that is 12. So your final answer is QR is equal to 12. If the unit is given, you write unit. If nothing is given, then no need to write any unit over here. Okay, there is no unit of centimeter meter, so it will be just 12. So this is the answer of question number 1. We have used here Apollonius theorem. Now let's see what is the question number 2. Now in question number 2, we will read and we will draw that figure. In triangle ABC, AB is given 10, AC 7, BC 9. We have to find the length of the median drawn from the point C to side AB. So let's draw one rough figure of triangle ABC. Anyway, you can draw A, B, C. AB is given 10, AC is, if you find this is, AC is bigger than AB, you can make it here B and here C. As it is rough figure, if you don't do, that's also fine. So if AC is now 7, smaller than AB 10, BC is 9. Now find the length of the median drawn from point C up to the side AB. So from here we want this median, so this can be the tentative midpoint. Okay, so let's take this point, say to be D. D is midpoint, this AB is given to us 10. Now we have to find this length of the median. Okay, so how we can write this as we have drawn this figure? Let's now in triangle ABC, let CD is median from point C to side AB. To side AB. Why we have written let? Because that point is not given to us, which is the midpoint. That's why we have taken. We are assuming that this is the midpoint. D is the midpoint of AB. Okay. Now, from this, so using now Apollonius theorem, therefore by Apollonius, don't do mistake in the spelling of the word Apollonius theorem. Now, D is the midpoint of AB, correct? So what are the two remaining sides? So left side of this, two remaining sides are AC and BC. AC and BC. Take squares and their sum. And right side it is 2 times. Write this in this way, you will never go wrong. 2 times what is the median? Median is CD, it's CD square. And 2 times half of the side. It's either AD or DB. So it is AD you can take. Okay. So half of the AD square. Now do we know AC square? Yeah, we know AC. AC is given to us. It is 7. So it is 7 square. What is BC? BC is 9. 2 times CD. That we don't know. 2 times CD square. Plus 2 times AD square. We don't know AD, but we know AB. What is AB? AD is AB upon 2, the whole square. So what is AD square? AD is nothing but half of AB. Okay. So now here let's simplify this. So we can put the value of AB here. Okay. So 7 square is 49 plus 9 square 81. That is 2 CD square plus 2 times AB is what? 10. 10 upon 2, you can write here that phi square. Or if you have written before also that AD is half of AB, that is phi square. Okay, so now add these two, or you can make it here 10 upon 2. In the next step you can do it for phi. Add this 9 plus 1 10, 8 plus 4 is 12 plus 1 13, 130. It is equal to 2 CD square plus 2 times 10 upon 2 is what? 5. 5 square. You can get it 25. Okay. Now divide this whole equation by 2. Here you will get it 65 is equal to CD square plus 25. Therefore, subtract this 25 from 65. You will get it is equal to CD square. Hence, CD square is equal to 40. And that's why 65 minus 25. That's 40. Okay, so 40 is, so CD is equal to what? It is under square root 40. What are the factors of 40? You can take perfect. It can be 4 tens are. So it can be 2 root 10. Fact, square root of 4 is 2. 2 root 10. So this can be your answer. So length of your answer can be in words. That length of the median from C to point AB is 2 root 10. So this way you can write the final answer. Okay. This was question number 2. Now let's go for question number 3. Okay. Now in question number 3, what is given to us? It's given that PS is the median of triangle PQR. Figure is already given in the question. This is triangle PQR. PS is the median. It means point S is midpoint of QR. And PT is perpendicular to QR. You have to prove PR square. That is PR. So this is your PR square. So this is your median and this is your altitude. PR square is equal to PS square plus QR. This is QR into ST. Okay. Plus QR upon 2 the whole square. QR, this is QR upon 2. So half of the QR. Either it can be SR or it can be QS. Okay. So if we are talking about this triangle PQR and this is the perpendicular drawn over here, it means if this T is 90 degree, then S angle should be acute. This angle should be acute. Okay. If this is acute, this PSR should be, obviously it is an obtuse angle. So to get PR square, which is an obtuse angle triangle. So if you think just only this part, okay, this is PSR, where S is an obtuse angle and this T is perpendicular here. Okay, what we can get? We can get side opposite to obtuse angle, that is PR square is equal to sum of the squares of remaining two sides of the triangle. So it is PS square plus SR square. It is 2 times SR into ST. So 2 times the angle vertex till the whole base and angle vertex till the foot of the perpendicular. So this we can get it. Now what we want? We want PR square is equal to PS square. So we want this PR, PS. Now here it is we want QR into ST. Where is we have ST? ST is here. But it is QR. If you take 2 SR, twice of SR, what is twice of SR? S is the midpoint, it's median. So 2 times SR you can get it QR. So this you can replace as QR into ST. So this also we have got this term. And what is this QR upon 2 the whole square? Now what is SR? SR is nothing but this we can replace. SR we can replace as half of the QR. So this we can replace as QR upon 2 the whole square. Okay. So using the Pythagoras in obtuse angle triangle, we can prove this first step. Similarly, to get PQ square, this is PQ, this is PQ. Now in this triangle PQS, this angle is going to be acute angle. So if we are talking only of this part where this is PQS and this is T over here, this is acute angle. Okay, forget about this. Okay, we want this. So this is right angle. So the side opposite to the acute angle, that is PQ. PQ square is equal to, the remaining two sides are PS and QS. PS square plus QS square, it is minus 2 times SQ or QS into ST. This is our application of Pythagoras in acute angle triangle. We are just looking only this part of the triangle. Okay. And now PQ square. This is right side, PQ square is equal to PS square. Now what is QS square? QS is what? QS is half of QR. So QR upon 2. QS is again half of QR. So this also we can get here, this one. And minus 2 times QS. 2 times QS is again QS double is QR. This we can replace is as QR into ST. Okay. So this proof we have to solve with the help of application of Pythagoras in acute and right angle triangle. Okay. So let's solve this proof part. Answer number 3. Proof. I'm just writing the proof part. Now in triangle PQ, let's take PSR. In triangle PSR, or let's write first, let's write PT is given perpendicular to side QR. This is given. Okay. Therefore, angle PSP is an acute angle. Okay. In triangle PTS. Now PST is acute. It means PSQ is also acute. Therefore, PSQ is an acute angle. Okay. The reason is P dash T dash S. If PSQ is acute, PSR is obtuse. Angle PSR is an obtuse angle. Okay. So this we can say statement number 1 and 2. Now in triangle, to prove this first, in triangle PSR, this is angle PSR is an obtuse angle. Okay. Therefore, by application of Pythagoras, its side opposite to it is PR square is equal to PS, this is S, PS square plus SR square plus this 2 times SR into ST. SR into ST. Now we have to replace this SR as half of QR, correct? Therefore, PR square is equal to PS square plus SR is what? QR upon 2 the whole square plus 2SR. This we are going to replace QR into ST. Reason is QR is equal to 2 times SR, or your S is midpoint. Okay. So this is your statement number 1. Just replace it second and third term on the right side, you get it proved. Therefore, PR square is equal to PS square plus QR into ST plus QR upon 2 the whole square is proved. This is the first thing. Okay. Now similarly you can prove in triangle PSQ, where that is an acute angle. So side opposite to acute angle, that is PQ square, is equal to remaining two sides PS and QS. Take their squares and addition. And as it is acute angle, you have to do the third term minus 2 times the whole base, that is QS, into from S point till the perpendicular ST. This is the application of Pythagoras in acute angle triangle. Now PS triangle, PS can be as it is. QS is nothing but it is QR upon 2, the whole square, minus this 2 times QS. It is going to be equal to QR into ST. Here the reason is same. QR is equal to 2 times QS. And therefore PQ square is equal to PS square. Just write this term here first. QR into SP and then write QR upon 2 the whole square. Okay. This is proved. So this was your second statement to be proved. So here in this way we have solved first 3 questions from practice set 2.2. The rest 2 sums we will solve in the next video. I hope you have understood this all 3 sums. Please give us like and comments, and if you are not yet subscribed to the channel, please subscribe. Thank you very much.